Lesson 5-7, least common multiple, and in this lesson you learn to find the least common multiple of two or more numbers. When are you ever going to use this? You can use the least common multiple to help you lay tile on a floor or a wall. Words we are going to use or learn in this lesson would be multiple, common multiples, least common multiple, or LCM. Let's take a look at this example. Jose is shopping for party supplies. He finds a package of 10 plates, a package of 16 napkins, and a package of 8 cups. What is the least number of packages of plates, napkins, and cups Jose can buy so that he has the same number of plates, napkins, and cups? We will solve this in example number 3. And this is a classic example of a least common multiple problem. Okay? We'll solve this later on in example 3, but before we do that, we need to use multiples, and let's define what a multiple is. Definition of a multiple of a number, okay, is the product of the number and any whole number. Okay, so when you talk about multiples of 2 and 3, going back to the definition of a multiple, it's saying that it's a product of the number and any whole number. Okay, so if you have them, if you want to find the multiples of 2, we need to multiply 2 with any whole number, and let's do it in order. Okay, 0 is the first whole number, so if I multiply 2 by 0, 2 times 0, that would give me 0. So 0 is the first multiple of 2, and if you notice, that will be the first multiple of any number. Okay, 2 times 1 will be 2, 2 times 2 will be 4, 2 times 3 will be 6, 2 times 4 would be 8, 2 times 5 would be 10, 2 times 6 would be 12, okay, and so on and so forth. So the multiples of 2 are 0, 2, 4, 6, 8, 10, 12, and so on and so forth. Let's find multiples of 3 this time. 3 times 0 is 0. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and so on and so forth. So multiples of 3 are 0, 3, 6, 9, 12, 15, 18, 21, and so on and so forth. Okay? If you notice that 0, 6, and 12 are multiples of both 2 and 3, 0, right here, 6 and 12 are all multiples, are all common multiples. Okay? The least of the common multiples of 2 or more numbers other than 0 is called the least common multiple. So the least common multiple, so you look at 0, 6, and 12, okay, of 2 or more numbers other than 0, that means we're not counting 0, okay, is what we call the LCM. So in this case, our LCM would be 6, because this is the least non-zero common multiple of 2 and 3. Okay? So, let's take a look at example number 1. Determine whether 65 is a multiple of 13. Remember, going back to the definition of a multiple, okay, it is the product of a number and any whole number. That means when we divide 65 by 13, the remainder should be 0. Okay? Or we can just list it. So we get the multiples of 13 start with 0, 13, 26, 39, 52, 65, 78. We hit it right there. So 65 is a multiple of 13. Okay? So in finding 0, 13, 26, we simply do our whole numbers. 3 times 0 is 0. 3 times 1 is 13. 3 times 2 is 26, and so on and so forth. Now, if you want to find out if our answer is correct or not, we simply get 65 divided by 13, okay? And we should get a whole number, which is 1, 2, 3, 4, 5, 6, which is 6, okay? And there are no remainders. So let's see how to find the LCM, okay? of two or more numbers. To find the LCM, you can either use one of the following methods. Okay, make a list. We know this. That means use several multiples of each number. And then identify the common multiples, and finally the least common multiple is the LCM. Okay, method 2, we discussed that in example 1, is use a calculator, list the multiples of the greater number, and then divide the multiples of the greater number by the lesser number until you get a whole number quotient. Okay, so whole number quotient meaning there are no remainders. And the last method is probably the best method. We will be using this, or you will be using this for a very long time, all the way to high school. So use prime factorization. So first write the prime factorization of each number, and then what we do is identify all common prime factors, then find the product of the prime factors using each common prime factor only once and remaining factors. This is the LCM. Okay, easy to read, hard to do, so I'll show you later how to do that. Okay, and let's find the LCM of 4 and 7 using methods 1 and 2. Let's use method 1 by listing. So multiples of 4, okay. Want to find the multiples of 4, 0, 4, 8, 12, 16, all the way to 28. Multiples of 7, 0, 7, 21, 28, 35, all the way to 42. And we found it, which is the least common multiple. The least common non-zero multiple would be 28. Method 2 again is using a calculator, using division. Multiples of 7, okay, and multiples of, okay, look at this. So now you have 7 divided by 4 would be 1.75. Okay, then you continue dividing until you get a whole number. 14 divided by 4 is 3.5. Okay, finding the multiples of 7. 21 divided by 4 is 5.25, and 28 divided by 4 is 7. Okay, so this tells us that the LCM of 4 and 7 is 28. Okay, that's method 1 and method 2. Let's take a look at method 3 in example 3, or that's right, example 3. Refer to the beginning of the lesson. What is the least number of packages, plates, napkins, and cups Jose can buy so that he has the same number of plates, napkins, and cups? So let's use the 4-step plan. First, you need to find the LCM of 10, 16, and 8. Okay, and then we need to use prime factorization. Okay, so using a factor tree or the drop down method, okay, the prime factors of 10 are 2 times 5. The prime factors of 16 again, using the factor tree or the drop down method, would be 2 times 2 times 2 times 2. And the prime factors of 8 would be 2 times 2 times 2. Okay, then we circle the common factors. So 2 is common to all 3. We circle that. Okay, and if you notice, 2 is the only common factor, okay, to all 3. So in this case, if we just want to find the GCF, or the greatest common factor, remember that the greatest common factor of 10, 16, and 8 is 2. But the thing is, we're not looking for the greatest common factor. We're looking for the LCM. So we do more steps to this problem. Okay, so after circling the GCF, okay, we move on. Okay, we know that 2 is common to 16 and 8, but it's not common to 10, but we still circle that. Okay, and then 2 is again common to both 16 and 8, but not to 5. We circle that. Okay, and the numbers that don't have pairs, we also circle once. And we bring down all the numbers that we've circled once. So this is a 2. This is a 2. This is a 2. This number, we bring it down once. That's a 2. And this number, we bring it down once as well, which is a 2, 5. And we simply multiply all of them. Okay, so 2 times 2 times 2, okay, times 2 times 5 will give us 80. Okay, so the product of that will give us 80. Okay, 4, 8, 16 times 5 is 80. That's right. Okay, so let's start answering the question. What's here? Oh, okay. Let me take out my others here. Let me bring these to the side so that it will not block the way. Okay. 2 times 2 times 2 times 5 will give us 80. Okay. Let me take those out so we can see what the... Let me just erase it a little bit right here. There you go. So we can see the bottom. Okay, so see, we need to answer the questions now. It's asking, what is the least number of packages, plates, napkins, and cups Jose can buy so that he has the same number of plates, napkins, and cups? So if our LCM is 80, we get 80, okay? And then what do we multiply 10 with to get to 80? Okay, using our LCM, which is 80, of course. Multiply 10 times 8. Then that means we will need 8 packages of plates. What do we need to multiply 16 to get to 80? That would be 5. So we need 5 packages of napkins. And what do we need to multiply 8 with to get to 80? Okay, multiply it by 10. So we will need 10 packages of cups. Okay, and that's if we examine this closely, each package will contain 10 cups or 80 plates, 80 napkins, or 80 cups. Okay? And that's it. Thank you for watching.